Let's take a look at a free response question from the 2017 AP Calculus exam together. If you want to try the problem first on your own, go ahead and pause the video now. Otherwise, let's go over it together. When a certain grocery store opens, it has 50 pounds of bananas on a display table. Customers are going to be removing these bananas, or I guess just buying these bananas, from the display table at a rate modeled by this function of f of t. Keep in mind that this f of t function is a rate, so it's how quickly these bananas are being removed from the table. In this function, t is time measured in hours, and our domain is restricted to when the store opens at t equals 0 hours and up to 12 hours, which is when the store is, I guess, going to close. So again, t is time in hours, and f of t is measured in pounds per hour. After the store has been open for 3 hours, store employees are going to be adding bananas to this display table at a rate modeled by this function here of g of t. So maybe they're running out of bananas and they just got to restock a little bit. This model represents how quickly bananas are being added onto this display table by the employees. And our domain restriction here is from 3 to 12, so the employees only start putting bananas onto the display table, or additional ones rather, when time is equal to 3 or 3 hours in, and they're going to do this up until 12 hours later. Similar to the function f of t, t still represents the number of hours since the store was opened, and g of t is still measured in pounds per hour. So what are we being asked here? Well, it looks like we're being asked to find this f prime of 7, or the derivative of that f of t function when time is equal to 7 or 7 hours after opening. So we have our f of t function here, which is letting us know how quickly the bananas are being removed from that display table, and we have that function right over here. Now, since this is a calculator question, we can go ahead and use a calculator to help us figure out what this f prime of t is, or what's that instantaneous rate of change at the 7th hour after opening this store. Now, a couple key important things here to note when you're taking the derivative of a rate function is that if f of t is greater than 0, or the derivative at a specific time value is greater than 0, that the rate is increasing, or the amount of bananas being taken off the display table is going up at that time. However, if f prime of t is less than 0, or is a negative number, means that the rate is decreasing, or the amount of bananas being removed from the display table is slowing down. Alright, let's go ahead and plug this onto a calculator and see what that's going to look like. Alright, so let's see, let's go ahead and put a graph right on here from Desmos. And this is what our graph looks like when you take that domain restriction from 0 to 12 of this function. Now, if you want to find out how quickly the rate is changing when the time is the 7th hour after opening, you would want to look at this t value, which is equal to 7, and you can see that the rate is going to be decreasing at that time. It has a negative slope there. So without finding the derivative of that time yet, if you just go ahead and graph it, you can see that this rate should be decreasing at that time because the derivative is going to be negative there. Now, once you've already defined your function into a graphing calculator like we did here, if you go ahead and type in f prime of 7, just like this, it'll go ahead and find you the derivative at this specific location of t is equal to 7. So feel free to go ahead and pause the video now to go ahead and do that. Now, if you do, you should be getting this value of negative 8.1195, and it goes on after that. Now that we know what f prime of 7 is equal to, we just have to go ahead and interpret what that means. If f prime of 7 is less than 0 or negative, that means the rate at which the bananas are being taken is going down. If f prime of 7 is greater than 0 or is positive, that means they're increasing the rate of bananas they are taking from the display shelves at time equals 7 or 7 hours in. And this is good to think about too. If f prime of 7 is equal to 0, that means that the rate at which these bananas are being taken from the shelves is just staying constant. It's not changing, it's just a constant rate of change. Alright, so let's go ahead and write a conclusion here. So we found the derivative when time is equal to 7 was this negative value here, which makes sense when you go ahead and look at the original function graph. It definitely looks like the rate of change is negative when time is 7. So let's go ahead and summarize what we just found. Since f prime of 7 is less than 0, the rate at which the bananas are being removed from the display table is decreasing by the 0.81195 bananas per hour. So I know these units can definitely be a little confusing because we have the bananas per hour, but then it's per hour here. But let's take a look at our function and see if this makes sense. You want to remember that this original function here represents the rate of change at which the bananas are being taken. So you can see that the bananas are being taken a little faster here, and then the amount of bananas being taken is slowing down. Then it looks like it's speeding up because people aren't taking bananas at a constant rate, right? So you can see at different times, the rate of change is going to be different. And at the specific time when t is equal to 7, the rate is just slowing down here. It's just people are taking it less and less at that specific time. If you look at these locations here, you can see that the rate of change is not increasing or decreasing because we have mins and maxes there, or relative mins and maxes. What that tells us is that the rate's not changing at those times. But you can also see here that the rates are increasing during these t values if you're looking at these parts of the graph, while the rate is going to be decreasing whenever you see each of these negative slope or tangent lines at those locations. All right, let's check out part B here. For part B, we're being asked, is the number of pounds of bananas on the display table increasing or decreasing at time is equal to 5? If the amount of bananas on the display table is increasing, that must mean that we'll have an overall net positive rate of change at that time. And if it's decreasing, we must have an overall net negative rate of change at that time. All right, specifically, we're going to be looking at when time is equal to 5, or 5 hours after the store opening. And you want to remember that original functions of f of t and g of t actually already represent rates of change. F of t is telling us how quickly the bananas are being taken from the display table, and g of t is telling us how quickly the employees are putting more bananas back on the display table. So let's take a look at these functions on a graph real quick. All right, so you can see here that I went ahead and just graphed both of these functions. So let's go ahead and look at these a little bit bigger here. You can already see our f of t function here. We also can see our g of t function over here. And we only really care about when t is equal to 5. So when we take a look at this first function at which the bananas are being taken from the display table, you can see that it's going to be at this rate of 13.79 or 13.80 roughly. We can see that the rate of change is going to be 13.8 around there, right? But for the amount of bananas that are being put back onto the display table by the employees here, you can see that that is going to be at this point right over here. And we can see that at time is equal to 5, or 5 hours in here, that the rate at which they're putting bananas back on those shelves, or on that display table rather, is going to be 11.53-ish. So while this rate of about 13.8 is telling us how quickly the bananas are being taken from the table, this 11.5 roughly is telling us how quickly the rate of bananas is being put back onto this display table. And so hopefully this makes sense when we go ahead and say that if we take this g of 5 and we go ahead and take away this f of 5, we'll find out this, net rate of change that we're dealing with here, right? If we find out this is going to be, if you plug this in, let's go ahead and put an approximation here. Looks like that's going to be about negative 2.263. I think that's what it's going to be here. Just use a calculator. You can see that this is going to be a net negative rate of change. So the important big idea concept that you want to kind of take away here is that because g of 5 is less than f of 5, that lets us know that the bananas is going to be increasing, the rate of bananas is going to be decreasing at time is equal to 5. They're not putting out as many bananas as they are being taken from that display table. Basically, the rate at which the employees are putting the bananas out is lower than the rate at which the bananas are being taken. So let's go ahead and summarize this real quick. Since f of 5 is greater than g of 5, or you can say g of 5 is less than f of 5, the number of pounds of bananas on that display table is decreasing at time equals 5, or 5 hours after opening. And just a quick side note, if this was reversed, if we found out that g of 5 was greater than f of 5, hopefully that makes sense, that means the rate would be increasing, or more bananas would be putting out than being taken away. And if these were equal to each other, that just also lets us know that the rate is not changing at all, that the rate at which they're being taken is the same as the rate at which they are being put back on. So we should have an equivalent rate there. All right, so that wraps up this video on this free response question from 2017. If you found the video helpful, please consider giving the video a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing.